Okay, so today we are going to show you how long it should take you to drop your 2K from a certain time to a goal. We've done a lot of research on this with the concept to erg and watts and just observing certain people and their methods to drop their splits. So what we're going to do is we're going to use 135, 620 as your goal split. You can plug in your goal and you'll figure that out. So anyways, the first thing we're going to do is we're going to convert your split into watts. And then we're going to take your watts and we're going to use that to find the moles of your 2K. So to find moles of 2K, we take split 2K, which is in this case is 135, and we know that one split 2K is 408.2 watts of 2K. So we end up with 82.5 moles of 2K. So next, we're going to plug it into the equation of the chemical equation of the concept to erg, which is 2FK plus AT reacts to create F2AT plus 2K. So we plug in the moles of 2K, and so that will give us how many moles 2K. We can find the limiting reactant and then determine the actual product of F2AT. But that's irrelevant because right now we're only worried about the kilojoules per mole, which is the enthalpy of the reaction. And we know that it's 539 because that's a given of the concept to erg. And we know that it's negative. We have to make sure it's negative because a 2K is an exothermic reaction. Therefore, heat is released into the surroundings. Because, you know, when you 2K, heat is created from the fan. But anyways, we get 375.2 kilojoules are produced when F2AT is burned by the erg. And the important thing to know is you cannot forget your sig figs. This is very, very, very important. Okay, now we have the kilojoules of the reaction of F2AT. Now we have to find the ionization energy of the fan. So how we do that is the equation for ionization energy is IE plus KE equals energy total. So we have the energy total because we're going to say that's this, the enthalpy of the reaction. So we plug that in, and we know another given of the concept 2 is when you're going 135 split, you can plug it into the concept 2 calculator, and you'll get 40 rotations per second, and that's your kinetic energy. And you'll get 3.00 times 10 to the 8th, and that is the ionization energy of the fan. So we'll graph these two. You can do this on your TI-84 and you'll get this. And we're going to find the tangent of the intersection. So I've drawn that here. I've put down the value. And we're going to find the derivative of that. So we do the definition of the derivative, f of x plus h minus f of x over h. You'll plug it in. You can do the math. We skip that here. But you end up with 4 minus 2 over 1, and we get 2. Now 2 is a special number. It's like E, it's like pi. We see it a lot in nature, and here's an example. If we have Spider-Man, if we multiply that by 2, we know the plural. We have Spider-Men. This is important if you notice. So times 2, and then we get 2 E's, 2. We can see it's a naturally occurring number. So what do we do with this 2? So with the number 2, what we can do is we can move that into our equation, which consists of divide by 2. So we take your skinny 2K, we divide it by 2, and we get the fat 2K.